We're going to spend about the next week on vector addition, and there are two main ways to add vectors. The first way is graphically, the second way is mathematically. And graphically is pretty simple actually. All you need is a ruler and a protractor, so that's why I asked you to make sure you have protractors. If you have them, I will have some for you for Monday. So graphical addition of vectors is essentially what you did in the pirate vector treasure hunt, where you were putting vectors together and then seeing where they ended up. So you were adding all of those different directions without really knowing that you were doing it. So I'm going to go through, I'll define what exactly a vector is in terms of drawing one. So we already know that a vector is something that has a magnitude and direction, and then we'll do some examples with adding them. So we already know vectors are going to have a certain length or magnitude and direction. And the direction is shown with the arrow. This is not working. There we go. And the length is shown with however long the body of the arrow is. And the parts of the vector, the arrow is the tip, and the back part is the tail. So when we add vectors, we're going to use something called the tip to tail method. So when I'm referring to tip and tail, just know that the tip is the arrow and the tail is the back part of the vector. All a tip to tail method does is add two vectors, tip to tail. So what does that mean? Say you've got one vector and you want to add a vector to it. You're going to start from the tip with the tail of your second vector. Say you wanted to add a third vector. You would start again from the tip of your previous vector and draw the third vector. Tip to tail. You can do this for however many vectors you have. When you get to your last vector that you need to add, you need to draw in a resultant vector. So the resultant vector is going to go from the tail of your first vector to the tip of your last vector. So our resultant vector would go this way. Tails match up, tips match up. And we usually name the resultant vector R. So let's say this was vector A, this was vector B, and this was vector C. What we did now was A plus B plus C equals R. So that's how you add the vectors. Again, I didn't do anything with measurements right now. I'm going to do that next, but just know that tip to tail method, you draw your first vector, you start at the tip of the next vector, and then every tip following. And then after you added all of your vectors together, you draw in your resultant vector from the tail of the first vector to the tip of the last vector. And the resultant is essentially your answer. So that's how you know what plus what equals whatever. Okay, so now let's add three vectors that have an actual magnitude and direction to figure out what the answer would be. I have vector A, vector B, and vector C. So if you were ever given these three vectors on a sheet of paper, what you would have to do first is figure out how long they are and what direction they're pointing in. So how long they are, I'm going to do this all in centimeters since we don't use inches. Vector A from the tail to the tip is 5.3 centimeters. So vector A is 5.3 centimeters at, and we say at to show the direction. The direction is measured from the horizontal. This is not dashing. You're measuring it from the x-axis, and you're going to center the dot or the cross, whatever is on the bottom of your protractor, at the tail. and see what the angle is. So following along the tip, this vector happens to be about 40 degrees. So this is 5.3 centimeters long at 40 degrees. And the next thing we need to do is show what direction in terms of north, south, east, west, north of south, east, north of east, north of west, etc. So how do we determine those directions? On any coordinate system, so here's your x-axis, here's your y-axis. North, south, east, and west. Anything in the first quadrant would be north of east. And a lot of times you'll see me just do an O instead of the whole of, so I would maybe write north of east. Anything in the second quadrant is north of west. Third quadrant is south of west, and fourth quadrant is south of east. So we always like to go in terms of the x-axis, whether or not it's north or south of east or west. So for vector A, this is 40 degrees since it's in the first quadrant, north of east. Vector B is from tip to tail about 3.2 centimeters long. So vector B is 3.2 centimeters at, and vector B is pointing in the second quadrant, so it's going to be whatever degree north of west. This is about 49 degrees north of west. You always want to use the acute angle, so no angle will ever be over 90 degrees when we're doing measurements. And then vector C is 4.1 centimeters long at, that's a bad at, let's fix that. At, this is directly east, directly east, so this is at east. You don't even need the at there. So this is just 4.1 centimeters directly east. Anything that points up, down, left, or right could be north, south, west, or east. You don't need any at there. So these are our three vectors, and what we want to do is now add them together. So we're going to do A plus B plus C. Okay, so now let's add A plus B plus C. To add these, we already have the measurements from the for measuring them, so the magnitude and the direction, and now what we need to do is redraw these vectors to those exact measurements using a ruler and a protractor to figure out what the resultant would be. So redrawing vector A. A was 40 degrees, 5.3 centimeters long, 40 degrees north of east. So, whoops, erase that, and erase that. 40 degrees north of east. I already made my 2 points with the protractor to get the 40-degree angle. And then we need this to be 5.3 centimeters long. So drawing in vector A. Again, you're using your ruler. I can't get a ruler very well right here. And we're going to label that A. Adding vector B to vector A, tip to tail method. Again, tail, tip. You're going to put the tail of B with the tip of A. And wherever the tip of A ends up, that's going to become your horizontal axis. So when you line up your protractor to measure the angle, you're always going to have the protractor horizontal. So the direction of your protractor is never going to be on some kind of angle or vertical. The protractor itself will always be horizontal. You're going to match up the center of your protractor with the tip of A. So the protractor should be centered right there. B was at 49 degrees north of west, so we want to make a point for that. That was about over here. And B was 3.2 centimeters long. So drawing B 3.2 centimeters long. Let me redraw that. Vector B goes right there. And it's okay if you have the dots for marking your protractor up there. That's fine. It's not going to make a difference. I like to use the reference points. You can erase it or you can leave it. Again, it doesn't matter as long as the vector is drawn to the right magnitude. So there's vector B. Then for vector C, we are 4.1 centimeters directly east. So once again, the tip of the last vector you drew becomes your x-axis. You're going to center the protractor right here. This is directly east from that point, and it's 4.1 centimeters long. So you don't need the protractor for anything in terms of angles. I'm just using mine as a ruler. So vector C is going to come out to about here. And then you're going to draw in vector C. It goes directly east from B. So A plus B plus C is what this would look like. Our final answer would be the resultant. So A plus B plus C equals R. The resultant goes from the tail of your first vector to the tip of your last vector. And you want to use a ruler to connect these. So tail of my first vector to tip of my last vector. It can go over any arrow. It doesn't make a difference. Going from here to here. And draw an arrow in. So that arrows always meet up when you're drawing in the resultant R. And what you need to do now is say what R is equal to in terms of magnitude and direction. So the same way we measured A and B and C using a ruler and a protractor, vector C is 8.6 centimeters long at the direction for vector C is 42 degrees. It's in the first quadrant, so it's north of east. So when doing vector addition, this would be your answer. A plus B plus C equals 8.6 centimeters at 42 degrees north of east. There is some leeway in the measurement and the measurement of your magnitude and direction in terms of the degree and the centimeter measure, because I know that graphically this has some room for error. However, you need to be in the ballpark. So this direction needs to be correct. I'd say you can be within about 0.5 plus or minus centimeters and plus or minus about 2 degrees when doing vector addition. As long as you're being precise when using the ruler and the protractor, you should be getting something very close to what it should be. Now let's subtract A minus B plus C using the same three vectors that we've already measured. Vector A was 5.3 centimeters at 40 degrees north of east, so we're just going to redraw A like we already had it. 5.3 centimeters. Whoops, that went in the wrong direction. Let's try this again. Vector A. Vector B, we're going from the tip of vector A, adding the opposite. If vector B pointed north of west, it's now going to point south of east. So you turn your protractor upside down. You're going to center it on the tip of A. Remember, your x-axis is still in line with the tip, so your protractor is still horizontal. It's just going to be upside down if you're subtracting. So centering this on vector A's tip, we have to find 49 degrees. So that's about over here. And the vector is 3.2 centimeters long. So vector B's opposite, we added the opposite of vector B to get that. Let me redo that arrow. vector B. And then we want to add vector C. So this is A plus a negative B plus C. C is 4.1 centimeters directly east, making the tip of B in line with the x-axis. We find 4.1 centimeters and draw in vector C. A minus B plus C. My resultant, we're still going from the tail of my first vector to the tip of my last vector. Connecting those 2 points, I'm going to do this in a different color. The arrows match up, the tails match up. This is my resultant R. And the last thing we need to do is measure R. So the resultant is longer than my 10 centimeter ruler right now. I'm going to say about 10.4 centimeters at, this is 9 degrees north of east. So there's my answer for A minus B plus C, this particular combination. We'll be doing a whole bunch of practice in class on vector addition graphically. You can either be given the vectors and have to measure them, or you can be given the measurements and have to draw them. Either one, you should be getting something very close and in the ballpark. So we'll spend about 2 days doing vector addition graphically, so we'll have a whole lab period as well as a whole day in class just to practice with this, and then we'll start doing it mathematically. And you'll be able to decide when it comes to the quiz whether or not you want to use the graphical or mathematical method, but doing both of them you should be getting about the same answer, so it's sometimes nice to know how to do both as a check. So in class on Monday, we'll be doing vector addition, so be ready to be drawing lots of vectors and using protractors and rulers.